Example 3. I want to write a rule for the nth term of the arithmetic sequence given a term a sub 19 equals 48 and the common difference is d equal to 3. Okay, so let's see if we can do that. To start off with, you might want to write down the rule. We know the rule is going to be a sub n is a sub 1, the first term, plus n minus 1 times that common difference d. Now, we don't know a sub n. We don't know a sub 1. What we do know is a sub 19 is 48, meaning the 19th term is 48. Or in other words, if I have a sub 19 equals 48, that means when n equals 19, I get an output of 49. So what I'm going to do is I'm going to use this formula, and instead of a sub n, I'm going to say, all right, my 19th term, or a sub 19, is going to be equal to a sub 1, which I don't know still. But instead of saying plus n minus 1, if I'm plugging in 19, my n value here is now 19, take away 1, times the common difference, which is 3. So I really have a sub 19. I know what this number is. It's 49. So I can change this into 49 equals a sub 1 plus 19 take away 1 is 18 times 3. I think you see where I'm going now. I can solve this equation for my first term, a sub 1. So I can get 49 equals a sub 1 plus 3 times 18 is 30 plus 24. I think that's 54. So we can subtract 54 from both sides, and I think we get negative 5 is a sub 1. So the rule would be a sub n is the first term, which we now know is negative 5, plus n minus 1 times 3. Now don't leave it like that. Just like the other examples, we want to distribute. So I get a sub n equals negative 5 plus 3n take away 3. So if I simplify by adding the like terms, I'm going to get 3n minus negative 3 minus 5 is minus 8. This would be the rule. And by the way, just thinking about it, I think on the previous example I forgot to evaluate, I think it asked for like the 15th term. So just to show you what that would be, and I apologize for forgetting to show you that, if I use my formula, all I have to do is plug in 15 for n. So a sub 15 would be equal to 3 times the n value is 15 minus 8. So 3 times 15 I think is 30 plus 15, that's 45. Subtract 8, that's going to be 37. So a sub 15, if I needed to know my 15th term, it is 37 in that sequence. Let's do one more example, and we'll call it quits on this video. This one's kind of the most involved, the hardest of the examples. Let's call this one example 4. And what we're going to do again is find the rule for an arithmetic sequence if I know two terms. And let's say I know that the 8th term, or a sub 8, is 21, and let's say I know the 27th term, a sub 27, is 97. So this is still the same idea. I want to get the rule, but now I know just two terms. Well, what I would do is start off by writing your rule. A sub n is going to be a sub 1 plus n take away 1 times the common difference d. Now, unfortunately, I don't know the a sub 1, and I don't know the common difference d. However, I do know two different coordinates or numbers of the sequence that I can substitute into the formula. If I plug in a sub 8, my 8th term, I can change the formula into a sub 8 equals a sub 1. I still don't know what the first term is. But as soon as I plug in a sub 8, I'm saying that n, the value of n, or the term I'm looking at is the 8th one, minus 1, and I still don't know the d. So I can change that into the following. Even more than that, I'm going to change what a sub 8 is. A sub 8 equals 21, so I can put 21 equals a sub 1 plus 8 minus 1, isn't that just 7? Let me just write 7d. So I have an equation here. Let me kind of box it. I have an equation that's got two variables, a sub 1, the first term, and the common difference d. I can set up another equation just like it using this term. Using a sub n equals a1 plus n minus 1 times d. I know my 27th term, so a sub 27 is going to be a sub 1 plus the n value is 27 here, take away 1 times d, and a sub 27 is 97. So I'm going to plug 97 here equals a sub 1 plus 27 minus 1 is 26d. Here's another equation that's got two variables, and I need to solve for it. Well, essentially, guys, I have a system of equations here I can solve. What I would do is this. Let's rewrite this guy right underneath. 21 equals a sub 1 plus 7d. And what I'm going to do is I'm going to subtract this entire equation from the top equation. If I subtract, I'm essentially going to distribute the negative on each of these terms and then add it to the previous one. So let me rewrite what we have here. We're going to have 97 equals a1 plus 26d, and then if I distribute the negative, I get minus 21 equals negative a1 minus 7d. And when I add these together, 97 minus 21 is 76. a1 minus a1 cancel. They've eliminated one of the variables for me. And then 26 take away 7 is going to be 19d. I can solve this now for d by dividing by 19. And I think if you divide 76 by 19, you get 4. So our common difference is 4. Now that I have that, I can easily solve for a sub 1. Like I can use this equation if I wanted, or the top one, it doesn't matter which. I'm going to use this one and say 21 equals a sub 1 plus 7 times 4. So I get 21 equals a sub 1 plus 28. If I subtract 28, I get negative 7 equals my a sub 1. There's my first term, there's my common difference. Now I can say a sub n equals the first term, negative 7, plus n minus 1 times the common difference 4, distribute, get a sub n equals negative 7 plus 4n minus 4. Adding like terms, give me a sub n is 4n minus 11. There is my formula.